Greetings. I'm Datesh Shenoy. In the next couple of minutes, I'll be walking you through a demonstration of my custom chatbot application that's using RAG framework and Azure AI Services. The use case for this particular application is to ensure that you use the existing capabilities of an LLM using your proprietary data as well. Now, before delving into the high-level architecture, let's have a quick look at the demo. So just a quick disclaimer. I have tried deploying this on AKS or container apps, but due to limited permissions, I've unfortunately not been able to complete the deployments. So this particular deployment here is a local deployment using Minikube. Let's quickly try something that's probably already stored in the cache, something like roles of a CTO. Now you see that it's returning the response from the cache, just took 1.47 seconds, and the reference is role library document. Now let's look at something that's not in the cache currently. How will I be assessed in the upcoming assessment year? Now this you see is from an LLM, and it took 3.38 seconds. It perfectly returns the expected output, and these are the sources. Now let's also quickly have a look at the database as well, where our documents are being stored. And here you can have a quick look at all the queries that we had asked and the corresponding response. Let's also have a look at Azure Monitor. Message contains or rather starts with station. You see, all of them have been logged. Now, just for this demo, I had ensured that the logging had a prefix tshanoi so that I could demonstrate how it's been logged. Now, this functionality is to also ensure that the application can be monitored on long term. And in simple terms, for traceability, this is something that will be extremely helpful. In this section, let's have a brief overview on the high-level architecture. As you've already seen in the demo, user will have access to a front-end Streamlit application. Now, at present, it's running on one single container on one pod, but ideally it will be split into front-end and backend running on two different containers in two different pods. Backend will use Python and Semantic Kernel. The entire thing will probably be hosted on AKS. And before we start our application, we would need one configuration out here, or rather two. So in Azure Foundry, you would have four different deployments. Now, two of these would be for evaluation as well, which we're not covering in this particular demonstration. You would ideally have a GPT-4o model, 4o mini, text augmenting 3 large, and ADA model. And also, you would index your specific documents, which in our case was specific to Contoso. That will be stored in a blob inside a storage account. You would ideally use document intelligence for OCR and then chunk it and then vectorize it. That will then be stored in Azure AI Search within an index. Now, this is also automated if you go directly via Azure Foundry deployment. For our cache, we'll be using Cosmos with MongoDB core. That's one other element. And as usual, we'll also be using application insights for logging. So just a quick brief on how a user query would flow through the entire application. A user would enter his or her query, which would then check if cache is enabled or not. If it is enabled, then you would generate an embedding out of that query, for which you would use the ADA model, text embedding ADA model. That will then be passed to the pipeline that will also ensure that your sources are also being listed, which will then query Cosmos DB, which you've already configured. And then if the relevant information is not available in the cache, you then directly go to retrieve documents. Now, retrieve documents would then fetch the relevant context from Azure AI Search, that is from this endpoint. The entire user query and context will be passed to our GPT-4o and embedding model, which will then return the relevant response that will be passed down back to the user. So this, in essence, is the entire configuration. And once it's being passed back to the user, it will also be logged into application insights just to ensure traceability as well. And for evaluation, you would have one more loop that would utilize GPT-4o Mini and text embedding 3 large models that will basically validate your model's outputs using another LLM. So that's how the entire architecture is currently devised. So this, in a sense, is an extremely high-level overview of how the entire application functions. For any additional details, the entire code base is available on my GitHub fork. So due credits to Pablo. Hi- The entire repo is forked from his repo, and these are just additional elements that are added on his code. So do check it out and let me know your thoughts. Thank you so much for your time. See you.